which says 2-gram sample of unknown solid is mixed with 20 grams of benzene. Pure benzene freezes at 5.533 degrees Celsius. Then the mixture freezes at minus 0.87 degrees Celsius. Um, and we are given the Kf, which is the freezing point of benzene, as 5.12 degrees Celsius per mole. So we are asked to calculate the molar mass of the unknown in this case. So let's solve this question. So 2 grams of unknown solid means the mass of our solvent. Okay, so mass of solvent is equal to 2 grams. Is mixed with 20 grams of benzene. So this is the mass of solution. Okay, so the solution in this case is benzene. So let's call the mass of solution, which is equal to 20 grams. Let's put this in the bracket. So this is the benzene as the solution. Okay, and then the solvent, which is unknown solid. So we don't know which solid is the solvent. Okay, and it says pure benzene freezes. Okay, so this is at 5.533 degrees Celsius. So this is the temperature of pure solvent. The pure solvent has a temperature of 5.533 degrees Celsius. Reading on, it says the mixture now freezes at minus 0.87 degrees Celsius. So this is now the temperature of the solution. So the temperature of the solution, okay, is equal to minus 0.87 degrees Celsius. Okay, so reading on, it says the freezing, that is the freezing point of benzene, that is Kf of benzene, is equal to 5.12 degrees Celsius per mole. We have to calculate the molar mass of unknown. Now we've brought out all the parameters. Now it's just for us to solve mathematically now, okay? So the first step we need to find here is the change in Tf, okay? So we have the change in Tf is what we have to find now. So we have a relation which says that change in Tf is equal to the temperature of pure solvents minus the temperature of the solution. Okay, so now we have this. So for us to get the Tf now is going to be the temperature of the pure solvent, which is 5.533 minus the temperature of the solution, which is minus 0.87. So let's simplify this with the calculator. 5.533 minus, that is plus 0.87. So we have a value of 6.403. So this is our change in Tf. Okay, we have it at 6.403. All the formula for freezing point depression, which is change in Tf is equals to IKF times m. Okay, so now we have gotten the change in Tf. But what we are looking for in this question now is the molar mass of the unknown. So now let's go to the molality. Remember that the molality is equal to moles of solute over mass of solvent. Okay, so this is the moles of solutes all over mass of solvent. So now let's solve this. But what we are looking for now is the moles of solutes. So making moles of solute the subject of formula here, we have moles of solutes is equal to, when we cross multiply, that is molality times the mass of solvent. What makes this interesting is that we have all the parameters out already, but there's something that is missing here. We don't have this molality, so we have to find molality, and we can get molality actually from the formula, because we have the change in Cf, we have our Kf of the benzene, okay, and also we have I, which is equals to 1. So from here we can even find our molality, okay? So now let's use this relation to find molality. So it's going to, making molality the subject of formula here is going to be m is equals to change in Tf over I times Kf. So now let's substitute the values. Also, change in Cf, we've gotten that to be 6.403 divided by I, which is 1 times the Kf, which is 5.12. Remember, this is times. So now let's use our calculator to simplify this, okay? So 6.403 divided by 5.12 gives us a value equal to 1.25 moles. So now we've gotten our molality. Now we can substitute into this expression to get our mass of solute. So this is equal to the molality, which is 1.25 times 2 divided by 1000. So simplifying this gives us a value of 1.25 times 2 divided by 1000. So we have, using our calculator, 1.25 times 2 divided by 1000, and this gives us a value of 0.0025 moles. So this is the number of the moles of the solute now is 0.0025. But what we are looking for, remember, is the molar mass of the unknown. So for us to get the molar mass, so this is the last step now. This is that the mass of the unknown solid is 80 grams per mole. This is just as simple as straightforward, okay? Whenever we see a question, we should be able to, identify what is the solution and which one is the solvent or the solute, okay? So it's just as simple as that. If you have any question under this topic, kindly drop your questions and we shall take it up from there. Remember, the video is sponsored by Proch Connect. I remain your pro guide, Aisha Bende. Thank you for watching and see you in the next class.